Hello. Check. Hello. Check. Hello. Just check if I'm audible. Yeah. Hello. I'll just wait for like 2 or 3 minutes and I'll start off. Making a first-person controller in Unity. So right as of now, I've loaded up a sample scene in Unity. Like my Unity window could be different from yours. It's completely fine. So like in the hierarchy, I have this asset that I downloaded from the Unity asset store. Sorry. And so yeah, let's start off. So we have to understand, like, first of all, how the camera of the first person controller of like any FPS works. So like the main key difference between a first person and like a third person view is the camera, right? Like in third person view, the camera focuses a an eagle eyes perspective, or like a different camera which is placed outside the player. In first person controller though, the camera is actually placed inside the player. So first of all, let's start off with creating the player first. So also before that, I would like to like explain the entire scene. I have the main camera set up over somewhere over here, right? Good. And the environment contains all of these like stuff, including the plane and the directional light. And light is, I don't know, it's somewhere, right? We'll see, figure it out later. And so yeah, so I'll start off with creating a capsule. This capsule will basically encapsulate the player's body. Let's name it first person controller, or let's say first person player. And inside it, we can see that there's like a capsule ready over here. I'll just drag like it really close to the ground, and yeah, let me just adjust my perspective a little bit. So yeah, So this is my capsule. It will contain my player. So first of all, I like to like sort of rescale my player. Let this be 1.5.1.5.1.5. Cool. This works. Let me just reposition it so it actually touches the ground. So yeah, now I'd like to throw some light on the properties of this particular capsule. It has one capsule collider. So like a collider in Unity basically works as like interactable sections that can interact with other colliders and like create very cool like physics related stuff. We'll come to that later. So as of now, I've created the main skeleton of my controller. Inside it, I actually want to create one other cylinder. So many times, like usually what happens is that like when you actually working on a particular project, and let's say you have a particular model, you should not like ideally import the model. You should create a skeleton of a capsule first and then import a model inside it. The reason behind this is there's a specific feature of Unity I'll be using later on called the character controller, and the default structure of the character controller is actually a capsule. So just to like make them to like very aligned, I'm just gonna like make the skeleton as a capsule and then like add a model, or let's say in my case a cylinder. So let me just create a cylinder over here. Okay, this cylinder I'll place it inside my first person capsule, and I'll remove the mesh renderer so I can only see the cylinder. And let's just rescale the cylinder to as wait 1 1 1. Cool. Works. Yeah, should work. My player. Where is my camera though? Yeah, right over here. So to place the camera, I'll just use isometric view. It should be placed in a manner that like its head is like right sort of above the player. So as of now, my main camera is lying somewhere at around okay here. Definitely not the place I want it to be. Sorry for that. I think this could work. And let's see what's the perspective of camera. I think this sort of works. Yeah. So right of now I've like also one more thing. So like I want the camera to be inside my player as an object of this particular object. So like as soon as I like change the position of my player, the camera also changes the position accordingly. So now I would like to implement the camera logic. The camera logic actually like refers to like how the camera interacts, like responds to your interaction with your mouse. So let's analyze what happens over here. Like as you move the mouse in the horizontal axis, your player rotates. And since the camera is inside the player, the camera will also rotate. But like if you move the mouse in a vertical direction, your player does not rotate like vertically. So like your player does not like hit a front flip or a back flip as you move the camera upwards and downwards. It would be really cool if it does, but like we don't get into that right now. But like now, so basically only the camera should move when I'm moving with the mouse vertically, and my player should move or rotate degrees to plus 90 degrees, so that I can not like look all the way. I can just like clamp my visible angle, right? To make add like some sort of realism to that. So I'll start off with adding a camera look script. Let's just call it mouse look. Yeah. So also this is a very good like method to like organize the entire workspace. So I'll just like create a folder called scripts and just add this cute little script over here. Cool. So let me just open this script. Just give it a moment, it's opening. Yeah, cool. So now I have the script opened in this Visual Studio. So first of all, now my entire logic will revolve around getting an input from the mouse. So let's call it a variable mouse x that will take the input from the horizontal movement of my mouse, and for that I'll use the inbuilt method dot input dot get access, and I'll use the key code mouse x for the horizontal input. I'll multiply it with a specific mouse. Let's just define this variable right now. Let's call it mouse sensitivity, and let's just assign it by a default value of like 10. And I would like to multiply this entire thing by the difference of time. So like what happens is, right, if you do not do this, like right off now my Unity project is working in 30 fps, but like as soon as this thing will be ported to a 60 fps port, this thing might malfunction. So to keep that thing sort of constant, I am just gonna like multiply this by the change in time. So time dot delta time is the inbuilt method for that, and similarly I'll get my horizontal input as mouse 5. The time dot delta time. So first of all, let me just like implement the horizontal rotation. So for that, I would like to have like an instance of an object that I want to rotate. So let's just call it like a public transform player body. Now this player body will be the actual object that I'm gonna like rotate as I move my mouse from left to right. Also, let's just make this mouse sensitivity variable public so that I can like actually change it in my Unity editor. And along with my player body, I don't think we will require any such thing as of now. So like let's just start off with this. So let's suppose I move my x like mouse horizontally by like some x units, right? So I want to like rotate my player by that amount in angles. So I'll just call the rotate function on my player body object. Rotate function is basically an inbuilt method of a public or not a public transform, a normal transform in Unity. So I'll simply rotate this in x direction. Wait, it's, yeah, cool. So as of now my script should work perfectly for x rotation. Let's just check. All right. Okay, the variable player body of mouse look has not been assigned. This is because I didn't assign the player body that I want to rotate. So let me just assign over here. So yeah, as you can see, the camera is facing a very weird angle. It's completely fine, and I'm able to rotate my camera from left to right. So big dubs in that. Also, I might change the rotation of camera. Oh wait. Yeah, now it's famous better. Good. So yeah, going back to the editor. Now I want to implement Y rotation. Y like the camera movement in the vertical axis. So for that, I need to know that I actually want to clamp my rotation from negative 90 degrees to positive 90 degrees. So for that, I'm going to maintain a variable. Let's call it Y rotation. Okay, and I'll clamp the value of Y rotation uh from 90 degrees to like plus 90 degrees. Wait, I have to clamp Y rotation from 90 degrees to plus 90 degrees, right? Okay, since it's a floating point number, I also have to mention this. Yeah, cool, works. And then I'll simply use a transform function to locally rotate the camera. Local rotation. So I'm rotating it by Euler angles with respect to my Y rotation variable. So yeah, this should hopefully work. Let's see. Okay. Okay, it's sort of working, but it's a bit messy in terms of rotation. Let me just fix that. And let me just increase my mouse sensitivity by like 5 times. So like yeah, it's working, but my camera is like placed in a weird direction. So like let me just like place it properly. This should work, right? Yeah, it does. So the camera logics have been implemented. Now I would like to like hand over my mic to my friend Anish to like explain how to implement basic movement.
Okay, hello guys. Am I audible? Hello, hello, hello. Thinks I should be audible. Okay, so we have the camera ready, but we need to put life into this game object, right? So this first-person player, it's doing nothing but just moving around. Like it's doing nothing, right? We need to add some life to it. So how do we add life to it? So basically, we put in a script. So first of all, this has a capsule collider attached to it. So this collider will react with every other object in the environment. So now we put in like another component to it called a character controller. So to make an object move, we have like two ways to do it. You can either use a rigid body or a character controller. So rigid body and a character controller, they both work in similar ways. They'll both react with like every other collider in the environment. So like as Shan mentioned, like so every other object has like a collider attached to it. So these colliders, what they do is they act as like an obstacle. They act as an obstacle for like every other element in the environment. So now this character controller will basically help us move around. And when there's a collision with any other environment, it's not going to basically go through it. It's going to identify that, okay, no, this is an object. I cannot go through this. I need to move around the environment. So basically that's what the character controller does. So now I want to add a script to it. So basically let me just go to assets, scripts, and add create C# script. So how does this work? So there's a naming convention when you want to name basically any sort of script. So first say I want to say character movement. I can't do this. There's a space between these names, right? So when I do this, so there's gonna be, let me just like put that. Okay, let me open this. Yeah, so when you see public class character movement, right? So when I put a space here, this is not going to recognize this is going to give me a warning that it's not a valid given context. So whenever you have like, so basically when you want to put in like any sort of name, just like put in like an underscore or like a capital so that it recognizes the name of the class. That's it. So now for the object to move, I'm gonna go to update. So basically whenever we create like, when the script starts, it's gonna go to start, void start. Void start is for one frame. and update is for all the other frames afterwards. So we're going to start through update. So before that, let me just create a couple of variables here. So public character controller will basically this is going to create an instance called controller for the character controller. So I'm going to use this name controller for like every time I want to invoke the character controller. So basically that's it for that. And then I want to create a player speed. Player speed will check the amount of speed the player is moving with. So we can't have like a basic. So when you want a character to move, you're gonna have to assign a separate speed to it. You can't have it just like move around without any specific speed attached to it. Then it's not gonna move basically. So I'm gonna also make the character run. So I'm gonna need like 2 variables for that. So this is gonna be 2. Yeah. So now I'm gonna put like 2 float variables to it. One is gonna be player speed and one is gonna be run speed. Then I'm gonna use a vector 3. So what vector 3 is? It is so any vector object in a 3D space is going to be defined with vector 3. So basically I'm going to do this for the velocity of the object. Alright, now let's move on to void update. I'm going to create something called a float variable, which is going to take input from my axis. So what is this get axis? Let me just go through horizontal. So this is the horizontal input. Okay, so let me go to the Unity here, and when I go to edit and then I go to project settings, so when I see input manager and I see the axis here, so there's an horizontal axis and a vertical axis. So basically whenever you put in like an input like WASD, so the input is going to be fetched from these axes. So that's what this code is for. So when I say input.get axis, it's going to fetch the horizontal movement from the particular axis. That's it. And then I'm also going to do the same thing for the y-axis. Then input. But rather, since I want to make this object move forward, I'm going to make it a z-axis. Input.get axis. And then vertical. So now I have both the axes set up. So after this, I'm gonna invoke my vector 3. So this was a vector object in the 3D space, right? So with this, I'm gonna create a transform. Right. Not forward. So I'm just gonna let you know what this does in a moment. The transform. So any kind of positioning of the object is going to be defined through this transform keyword. So this transform has the position, the size, the scale of any kind of object. So you invoke this transform and then you call the right function and the forward function. So right transform.right will basically move the object in the right left direction, and the forward will basically help the object to move in the forward direction when you call the z-axis. So this will give me the direction of the object. So this entire vector 3D space is going to give me the direction. So I've only called the x and the z axis because I don't need the y axis here. I just want the object to move around and it's not going to jump for a while now. So that will be later on. For now, I just want the object to move, and this will define the direction of the object. Now, let me take an input. So I'm going to put in like an if statement here, and this if statement is going to divide my movement into a running and a basically normal movement. So how do I do the running implementation? When I do input.get key, I'm going to say key code dot left shift. This will basically help me differentiate. So when I click on left shift, So this get key will invoke the left shift movement. So when I hit on left shift, it's gonna say, okay, so I can recognize that there's a left shift which is being pressed. So now what else am I gonna do inside this left shift? So I'm gonna make this controller. So now remember the character controller instance I created beforehand. So I'm gonna call that character controller here, and then I'm gonna make it move such that there's a move times the run which I created beforehand. That was the variable. Times time dot delta time. Okay, so what does this do? It's a controller dot move. So basically, it's invoking the direction. I give it the direction, I give it the speed, and the amount of time difference which is there. So when there's different number of frames when the user is playing, there's going to be a couple of different frames. So this time of delta time is basically to smooth down those frames. So it's going to check based on what kind of time I'm getting, and then the movement is going to be streamlined into every kind of frame. So that's what that is. Okay. So this was for one input when the left shift key is pressed. So now I just want it to move around normally. That I'm just gonna create a controller, same thing again, but instead of run speed this time, I'm gonna give it the normal speed. Okay. Alright, that's it. This for now should help me move around. Okay. Alright, now let me just go here, and I'm gonna add this component, the character movement script which I had. Okay, and I'm also gonna place the character controller here. So basically, since I've created a character controller instance here, code is gonna invoke that particular character controller, and through that character controller, I'm gonna basically run around. That's it. So now if I just like go here and run this. Okay, so that's the, yep, as you can see, it's moving in the forward direction. Back, it's moving, it's back and forth. See, it's gonna, when I go to object, it's gonna collide with that object. So that's what the character controller is for. So it's gonna react with the other environments in the object, in the other objects in the environment. That's it. And that is it. So whenever you see an object, it's gonna collide with the collider. It's gonna stop moving around. Now my character is alive basically. It's gonna move around like this. Yep, it's working perfectly. Now when I want it to sprint, I'm gonna hold the left shift key. If you see, the speed has been doubled. I just wanna, let me just like, just so I can demonstrate there's a massive difference here. Let me just do something like this. So now let me just see. So when I'm not sprinting, right, this is gonna move very slowly. You can see it's not moving at all because I've adjusted the player speed to 1 and the run speed to 50. So it's not moving at all. It's very slow. And let me hit on the sprint, and it's just gonna speed through the entire fucking thing. Okay, yeah, that's it. Alright, now I'm gonna get in Shan again. So now the player has started moving, but we also need a gun to like put an FPS rate. So basically, Shan's gonna help with the gun mechanics and the gravity and the jump.
So, hello there again. So as of now, we have the basic controller movement, but right now I also wanna like add jump mechanics. And so before that, first of all, let me simply add gravity. So as of now, I just placed my character at a specific height, as we can see over here. So now I want that whenever I hit point. So let me just create a public float called gravity and initialize it by the universal gravitational constant of whatever that shit was, minus 9.8, right? Go. And in my inside my update function, what I'm gonna do is I'm gonna simply say that my velocity in the y direction, Okay, for that I also wanna like create a vector 3 velocity. Okay, I've created over here. It's not being used yet, so let me just use velocity in the y direction. I'm increasing it by gravity times this difference in time. So here comes in some of the physics that I've learned in my previous classes. We know that v is equal to u plus at, right? And a over here is gravity, and t is the difference of time, that is time dot delta time. So that's why my velocity in the y-axis is basically my velocity, initial velocity at every instance, plus gravity into time. So from here I should have implemented gravity, so like let's check it. Okay, if I hit run, am I falling? Okay, it's quite interesting. Okay, let's see. Let me just try to debug this thing. Okay, also, yeah, I have to move this too, right? So I'll just write controller dot move into velocity dot delta time. Yeah, as you can see now my player is falling, as well I can move left and right. Alright, good. Let me just like schedule this player speed by like let's say 20 or like 10. Oh, and let this be 20. Let this be 5. Cool. So we have implemented gravity, but now I want to implement jumping. So like let's just like let me just replace this character like in ground. Yeah, I'm in ground right now. Cool. So now let's analyze how jumping works over here. Alright. So for jumping, let's see what happens. So like in any first person player, you can see that a player can jump by hitting the space bar, right? But at the same time he cannot jump once it's in air. So like like for now let me just like blindly like input jumping. I'll just write an if statement. If my input dot button is space bar, that is the button assigned to jump, and it as jump height. All right, and I'll move my player with that specific height. And since I've mentioned the height, I know what velocity I have to attain, because we know v square is equal to u square plus 2as, and since my initial velocity is 0, and I can say that v is equal to square root of 2as, where s is the jump height, right? So I'll just initialize that my velocity in the y direction has become square root. Mathf is like an inbuilt module that I'm using to like input features like square root and stuff. Wait, I just messed up. Yeah, square root of 2 uh times gravity, that is a over here, times jump height, right? All right, cool. Wait, also this has to be negative because I want to like go against the gravity. And let's just try. Oh wait. Okay, yeah, also yeah. I made the jump height as 0, so like let me just initialize it by a while as number, let's say ATF. So let me just hit play. Okay. Can I jump? No, I cannot jump. Let me just see what's wrong. Okay. Quite interesting. Let me just see. Okay, for that, let me just check if my if button is actually getting a jump input or not. So like, let me just debug this. Okay, so my space bar is being pressed, so like my code is entering this specific section. So there's something wrong with here, right? Let me just check. Just give me a moment over here. Yeah, I might have actually figured out what's actually wrong. Let me just increase it to 20. Check if it works now. Yeah, it works. Okay. So basically, I was like reinitiating my this jump height to 0 every time at like before I hit play. So it's fine. So yeah, am I audible, right? Good, works. So let me just like put it as a more believable value of like 5, and let's see how it works, right? Cool. So now I have implemented jump, but here's the issue. So I can jump like infinite amount of times. So like I jumped once, I can jump again. I can like basically cross the horizons of this specific world, which I don't really want, right? So I want a feature to like check if my player is grounded or not. So like I only want to jump if my player is grounded. I do not want a double, triple, quadruple jump, right? So for a check sphere, so this specific feature does what? So let's say this is my player body. Let's just color it red, and let's just create. I'll create an empty object called ground check, and let's suppose this is the specific ground I want to check. So the physics dot check sphere method provided by Unity, it basically generates a sphere from around ground check of a specific radius, and let's say it generates this sphere of, let's say, an r radius, and if a ground is like encountered within the range of this radius, it's gonna return yes, that yes, the body is grounded. And how it works is basically it starts like creating light rays from the center of the sphere or the ground check's position of a specific radius, and as soon as like it hits a specific ground or like a collider of that specific mask, it's gonna reflect back and it's gonna touch the point from where it came from, and that's how it will like analyze ki, yeah, the object is grounded. So as of now, if I make a radius of like, oh sorry, a big radius like this, I can see ki like the light rays will definitely strike the ground and reflect back to its origin point, and yes, it will return me yes in the ground check variable. So let's just try to implement that. So first of all, sorry for that, I'm gonna make an empty object, like let's call it ground check, right? And I'm gonna like place it inside my cylinder, and let me just reposition this. Not perfect, let me just try to make it perfect. Let me just rescale it as 0.2, 0.2, 0.2. Yeah, I think it's perfect now. So, and now I'll add the ground check variable inside my code. Let's call it public bool is grounded. And as soon as my code starts, the first thing I'll do is initialize the ground check variable. And so I'll write is grounded is equal to, I'll call the method provided by Unity, physics dot check sphere, and I'll actually have to add the position of the ground check object along with the radius and the ground mask. So first of all, let me just like create a public transform for the ground check object that we just created. So ground check. So inside the check sphere, I'll write ground check, not ground check, rather ground check's position from the point it has to instantiate like a sphere. And after that, I'll have to mention the ground distance, and I'll also make it like a public variable, public float ground distance, and initialize it by like a really small value, let's say 0.5 f. Okay, wait, e, right, good. And then I'll also initialize like a public layer mask. I'll explain what layer mask is. So basically, every element you can see like in the inspector view, there is a thing called layer, and by default it has default like a layer. So you can create different layers to like specify different functionalities. So as of now, let me just like layer, like make a ground layer for like every element in my environment. I can do this by like adding a layer in layer 6. Let's call it ground, right? And after that, I'll roll back, and inside my ground, okay, wait, let me just save this code. Okay, I'll make it like a public variable layer mask, and then have one layer mask over here. Okay, let's see it later on. Basically, it's a normal layer, right? So it will collide with every element marked with this specific layer. So now let me just call this ground mask. Good. So now this will return me if the object is grounded or not. And now how to implement it into the jump functionality, I'll simply add an AND statement inside the if statement stating that if my player is grounded, I'll jump. If not, I'll not do anything. So now I have my jump height as 5 and ground mask as nothing. So like let's make it ground now. And ground check, I have to mention it over here. Good. So now as I hit play, okay, it's returning me false even when like I'm actually in ground. This has something to do with the positioning of my ground check. Let me just position it a bit forward, like upwards. Let me just run now. Okay, wait. Okay, something is off still, right? Let me see. Okay, so I have to also initialize the layer of all the elements in my environment to ground. Let's see if it works now. Yeah, it works. So as you can see, like since I'm able to jump, my player is definitely grounded, but at the same time I cannot spam jump in the air because like its player is not grounded in the moment. Oh, it's a texture, never mind. So yeah, we have implemented jumping alongside gravity, right? First of all, let me just close this goofy ass semi-screen. Yeah. After that, I'll have to implement a gun because it's a first-person shooter, so like it sort of makes sense to have a gun, right? So for that, I'll simply import a model of a gun from my package manager. Let me just head over there. I have this cool little gun over here. Let me just import it to my project. So as you can see, like we have a gun ready for us. Let me just like place it inside my main camera or like cylinder, wherever you want, to be very honest. But like let me just place it inside the camera because it makes sense to like have the gun inside of a camera, right? So for now, okay, I have my model right over here. So let me just like drag it somewhere. I don't know where it is. Let me just rescale it. Okay. So this, but like I want it in the left hand side. And let me just place it inside the camera. And let me just like load in a specific prefab for this. Let's like load in a yellow gun maybe. Oh wait. Oh, okay. So yeah, I have my gun ready. Let's see how it like looks. Not perfect. I'll sort of doable, I guess. Yeah. So my gun's sort of ready with my camera, and now I wanna like start like shooting bullets from this thing. Okay. So again, let's analyze how do you shoot in any one of the FPS games or like in any game in general. So what happens is there is a spawn point in your weapon, which is usually the muzzle of the weapon, and as soon as you click the button assigned to shoot, it creates a specific object which is called the bullet, and then it throws that object in a very high speed. And to do that, first of all, let me create a spawn point. A spawn point again is like a empty like a object. Let's call it a spawn point, and I'll put this inside the main camera. Okay, let me just create an empty object called gun, place it inside the main camera, and like shove these two things in it. So now I have a spawn point. Let me just reposition it so like it's right at the muzzle of the gun. I don't know where it is as of now. Okay. Or you know what, I'm just failing to like position it. I'll just leave it. I'll just take it that there is a spawn point somewhere in the gun. Okay, cool. So now I'm just gonna tell you logic how to like make like this gun shoot things. So first of all, I'm gonna create a sphere. That sphere will represent the bullet. Let's make the bullet of some different. Okay, I cannot edit the material over here. Let me just create a different material. Let's just like make it dark reddish or something. Yeah, should work. Oh wait. Yeah. So I'll just name it bullet, and inside my bullet, I'll this looks somewhat more of a bullet. Uh, 0.5 should work, I guess. Yeah, cool. So now I'll make this bullet a prefab. Let me just drag it over here to make it a prefab, and I want to create this specific bullet as soon as I press my left mouse button. So for that, let me just go to my gun and add a different script called shooting mechanics. Okay, wait. Create an ad. And now, okay, let me just open it. Shooting mechanics goes under scripts, and here we go. Wait, what? Yeah. So yeah. Inside my shooting mechanics. So first of all, let me just say that if my input, like the button that I've input is my left mouse button, and like left mouse button is referred to in Unity as the key code of mouse 0. So I'll just write key code dot mouse 0. If this bullet prefab from a bullet spawn points position by a specific rotation. So let me just write everything over here. I'll create the variables later on. So bullet prefab from bullet spawn point position, and then I'll add the rotation of the bullet spawn point, right? And let me just create the variables over here. Bullet prefab is a transform. So let me just write bullet prefab. And bullet spawn point is also a transform that will have to allocate. And this should resolve all the errors, right? Cool. And then after making a variable, I'll simply like release the variable with a specific velocity. And for the velocity, I'll need to have another variable that will store the velocity of the bullet. And let's call it bullet speed, right? And let me just initialize it by 50. And we're almost done through this. And I'll get the component of bullet as rigid body. I'm basically changing the velocity of the specific rigid body by a specific speed, right? So I'll release the bullet in the forward direction with respect to the spawn point of the bullet spawn point basically, and I'll multiply it with the bullet speed. So this will basically create a bullet, and it will simply like project it with this particular speed. And yeah, this should like create my bullets from the spawn point. Let's see if it works. So okay, yeah, for spawn point I tend to assign the value of this prefab from here. And okay, wait, yeah, and then I'll also have to mention the spawn point, right? So, sorry for that. Okay, wait, what happened? No rigid body attached to bullet. Okay, let's just try to fix this thing. No rigid body attached to bullet. Okay. All right. So in my bullet prefab, I also have to initialize the rigid body since I'm using the properties of the rigid body. So yeah, here we go. This should do the job. Yeah, it's working. I won't say perfectly because like it's the spawn point is like bit to the right of the gun. Let's just fix it later on. Also 180 degrees maybe. Oh, still the same thing. Cool. Let me see. Okay, in that case, just to like hardcode this thing, I can like simply, if okay, that's not a keyword over here. Okay, let me see. Okay, cool. Now it's working. So basically, I just reversed the like direction of the bullet's velocity. It's fine. So now we have implemented shooting, and let's just see how like a game looks as of now. Not a game, rather like a model. So yeah, I can sprint. I can jump. It's a bit clunky, but like it's manageable. And I can also shoot stuff at like a marginally decent speed. So yeah, after that, I also there's one issue. So like as I shoot the bullets, right? The bullets tend to like stay in my project, and that's not very optimal to matlab, like make the bullets or like any basically kill the bullet after a set amount of time. Let me just create an art, like put this script inside my scripts folder, and let's just program it in a way so that it just kills itself after a specific amount of time. So I want to create like I want to destroy a specific game object, let's call it the bullet, and I want to destroy it after a specific time, let's call it time, and let me just initialize it as 5 seconds initially. I can change it according like to how I want. And inside I won't be using like update or start methods over here. Rather, I'll be using a wake method, and this wake method will basically start a coroutine. Let's call that coroutine wait, not wait for end frame, simply wait. And now let's like mention what is wait. I'll use it by I numerator, and this will basically create a delay of a set amount of time, and I'll generate a time delay by the help of the yield function. Oh wait, the return new wait for seconds, and I'll pass time over here. And then after this delay, I'll simply destroy my game object. So if I look at it right now, they are not going away. Okay, let me just see what's wrong over here. Okay, that's because I didn't mention what do I have to kill. So I'll just pass in the bullet prefab over here, and it should work now. And as we can see, after 5 seconds, it has like destroyed itself. Cool, works perfect. Let's get back to the code, or let's actually get back to the final layer of this controller, that is to like kill the enemies upon interaction. Okay, to like I'll explain this.
Okay, so now time to kill some enemies. So basically, let me just add another object for enemies. And enemies would be something like a sphere. Why not? So you want to put in like, let me just call this an enemy. Okay. Move this around somewhere. Make it a bit bigger. Down here. Down maybe. Should work. Okay. Now, so this is an enemy object. I want to create a tag which will define this object as an enemy. Let me just add a tag. Enemy. Go back. Now I want the so whenever this bullet, when I'm gonna shoot, I want this bullet to collide with the enemy, and then that's gonna destroy. Now I want to destroy this particular enemy when the bullet collides with the object. So for that, let me create a script. Let me just put scripts. New script. Or I'm gonna leave the void start and the void update as it is. I'm gonna go to void and I'm gonna use a function which is an inbuilt function on collision. On collision enter. So this on collision enter function is going to check when one collider impacts another collider. So when two colliders are going to impact together, it's going to invoke this particular instance of the collision object. Just name this as something other. We're going to go inside the function, and if other dot game object, so I'm going to use the game object dot tag. So since I put an enemy tag on that particular game object, it's going to search for that tag. This is what the if statement is doing. I'm going to search for the enemy tag, and inside the enemy tag, I'm going to say I'm going to destroy this particular game object. Other dot game object. This particular script should okay. So now here other was the collision instance, and I'm going to call that instance. So whenever there's a collision, it's going to invoke the game object and I'm going to destroy it. That's it. So now I'm going to go to the bullet prefab. Enemy kill here. Lights with the enemy. It's going to kill it. See? Terrible at shooting, so that's gonna take. Yep. So whenever it hits the collider, it's gonna kill the enemy. I'm just create some more enemies so that you can. So here. Okay. Let's just go through each of these. I'm just gonna okay, that's one. Okay, so basically get the gist of it. Now let me just create a material because all of these enemies have the same color. I don't want that. I'm gonna create a material which is gonna provide a different color for all the enemies. Just put assets. Order materials. Create material here. Or skin. And I can provide that shader there. Let me just give it yeah. Let me just provide the skin to all the game objects here. From here. Alright. See how the game looks like. One, two. So when you can go around, you can have the jump. Try to split off. Yeah, okay, that's a skill issue on my part because I'm pretty bad at shooting, but yeah, that's it. So that's it for the enemies. But like, so suppose I wanna animate these enemies. I wanna make them move around a bit. So I don't want it to just like stay put. So let me just go here, and I'm gonna go to assets and create another folder called animation. Now I'm gonna create an animation for this particular object. So let me just go to here. Computer animations, new animation. Okay. Move this around here for a bit. Now I'm gonna record this object to move around. First 5 seconds, I'm gonna make it go up. That was one. Next 10 seconds, I'm gonna make it go down. There's another one. Gonna repeat this for a bit. Just a second. Okay, I don't want it to be this quick. Let me just like space around the animations. Alright, now we have the enemy moving. So now if I play this, it should have the enemy move around. Yep, that's it. We have the enemy moving with the animation implemented, and when I shoot it, it's gonna kill the enemy. Yeah, that's it.
So thanks for tuning in. This is all for today. We learned how to make like a first person controller and how to move the player around, how to shoot, how the shooting mechanics work. And you basically got like an insight on how like basic game mechanics work and how do you think about implementing them. You can add upon this thing by like including double jumping, triple jumping, or even ball running. And I would like you all to explore more on this front.